Now we're going to talk about the symbols here that we're using. This is the nth root of a. N is called the index. The little check mark looking thing is called a radical. Okay, so that's a radical. And the thing inside the radical is called the radicand. So you have to remember these because I do use these words. The index is an integer greater than or equal to 2. If the index is 2, we usually don't write it, as I mentioned before. So that would be the square root of a. The cube root of a, the index would be 3. The fourth root of a, the index would be 4, etc. Right? So square root of a, we usually don't write the index 2. It still has an index 2, we just don't usually write it down. Perfect squares. In order to do the square roots, you need to know what the perfect squares, because we usually use these in algebra classes for examples. So we've got 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. These are all the diagonals of your multiplication tables, except for, I guess, 10 squared is 100. I think most people know that. 11 squared is 121. You have to know that, okay? 12 squared is 144. Know that. And 13 squared is 169. So, and that's as high as most textbooks would go. In fact, I don't remember ever seeing a textbook that expected you to know what like 17 squared is or something. So 13 squared. You can have products of some of these, like you could have 9 times 16. And then what you're going to do is do the square root of these things. So, for example, you have 0. Since 0 squared is 0, the square root of 0 is 0. 1 squared is 1, so the square root of 1 is 1. Those are the easiest ones. 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, the square root of 16 is 4. 5 squared is 25, square root of 25 is 5. 6 squared is 36, square root of 36 is 6. 7 squared is 49, square root of 49 is 7, etc., right? So you get the square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. That's why you need to have these memorized, because you're going from right to left when you're doing the square root. Square root of 81 is 9, etc. Okay. Now, in order to do cube roots, we need to know the perfect cubes. The first two are pretty trivial. 0 cubed is 0, 1 cubed is 1. And these are all the ones you need to know. There's a lot fewer because the numbers get big faster. 2 cubed is 8, right? 3 cubed is 27. So cube root of 27 is 3. That's important to remember. Cube root of 8 is 2. That's the, and the most common ones are the ones with the 2s, and then they get less common as you go up. Okay, so 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. I'd say actually 125 is probably slightly more common than 64, but they're still commonly used, so you need to know them. And 10 cubed is just a 1 with 3 zeros, right? It's 1,000. So cube root of 1,000 is 10. Cube root of 125 is 5. Cube root of 64 is 4. So these are called perfect cubes, because they're all the cube of some integer. And then we've got the perfect fourths, and there's fewer of those than there are of cubes that you need to know. Okay, so 0 and 1 are the trivial ones. 2 to the 4th is 16, right? 3 to the 4th is 81. It's 3 squared times 3 squared, if you remember your rules of powers, which is 9 times 9, 81. So the fourth root of 81 is 3. The fourth root of 16 is 2. Right? Fourth root of 0 is 0. Fourth root of 1 is 1. Fourth root of 625 is 5, because 5 to the fourth power is 625. And then 10 to the fourth is just a 1 with 4 zeros. 1, 2, 3, 4. So that's 10,000. So fourth root of 10,000 is 10. Okay? So you need to know all of those on that page. A lot of them you already know. Just kind of circle the ones that you don't yet have memorized or are not real confident about, and then work on those.